Okay, model data no more. What do I mean by that? First, we need to discuss what it really means to model data. What is data modeling? And the question is not as simple as you might first think. The debate was out there for quite a while. Here we've got an example from 1984 where data modelers were divided by a paper into semantic absolutists and semantic relativists. So absolutists think there is one ideal way to model a piece of data, and we just need to discover it. While relativists think there isn't one. There are multiple versions of what could be an acceptable solution. There's another view where you could divide people who model data into positivists and interpretativists. So positivists think that we discover the model. Interpretativists think we create one. You could also talk about objectivists and subjectivists, where the first one constructs the model, the other one tries to reflect reality. And when we do that, we really look at two main purposes for which we do it. We could look at the stakeholders and how we communicate with them, but also we could look at data modeling as the tool for database specification. So the main question here is data modeling, analysis, or design? If you think we are analysts when we model the data, you subscribe effectively to this positivist, subjectivist, semantic absolutism point of view, where there is a single true model which we are trying to reflect or discover. If we think about data modeling as designers, we think that there isn't one truth, that perhaps we are looking for a set of opinions and a way to present an existing reality. Does it really matter? I think this is a very important question, and to me it does. Because to stop doing something, we should first know what it really is, so we are sure we are not doing it. IBM defines data modeling as this. It's a process of creating a visual representation of either a whole information system or parts of it. The goal is to illustrate the types of data used. It talks about formats and attributes. Microsoft's definition? It is the process of analyzing. It creates visual representation of data, and it's used to help us understand and clarify our data requirements. Another one, SAP. Data modeling is the process of diagramming data flows. Data format structures, those things keep appearing again and again. So as you can see, it's all analytical. And if you look at our civil service approach, data capability framework, data modeling is about different types and about reverse engineering a data model from a live system. In our practical context, in our industry, data modeling is definitely analysis. Data modeling texts almost invariably support a descriptive view by limiting any discussion of choice in data modeling to choice of construct, whether we represent a real-world concept as an attribute or an entity, and providing only one solution to data modeling problems. And I think this is very important, and this is how I understand data modeling when I say model data no more. So we do data modeling, but why? We do it to understand what data we have. That's from the definitions we had. We talk about it to decide what types to use. We also try to figure out how to represent and store the information in tables. And we do that because we don't really understand the data we have, I suppose. We like to think we design things. That choice of data type seems to be that design element. And probably most importantly, it appears to me from my practice that we are comfortable with tables. The question really becomes, can we just not do it? Could we just stop data modeling? What would happen then? Well, there is a problem with the data storage and representation. We are used to modeling data so we can put it in tables and save them in relational databases. But the tools are already available which allow us to store the data which is not in that format. Representation, again, the main tool we use for data analysis, whether we like it or not, is probably Excel. But there are other tools to look at the data differently. Data types, I think once it was a very important aspect of data modeling. How can we efficiently represent the data? How can we ensure the data means what we think it means, but also that it's stored efficiently? As the technology progresses, I think this discussion is less and less important. There are better and better tools that offer good performance out of the box, and perhaps optimization that happens behind the scenes. So we don't need a trained data modeler to solve those problems. Understanding the data, right, that's something we really would like to do. We talk a lot about how important the data is. We are here at Data Connect talking about the data. I think I don't have to convince you that data-driven approaches to most things we do is valuable. Crucial to that is understanding what the data is. So it's not just ones and zeros, but there is something behind it, something bigger. But do we need structures, as in tables and columns and with column names and column lengths, to achieve that? Or is there a better way? So there are alternatives to relational database management systems. And no, I'm not really talking about NoSQL, although that is a technical solution to part of the problem. So we can have semi or unstructured data stored somewhere and being accessible. I'm talking about linked data and the resource description framework, also called RDF. What is it? In a sense, this is a data model. It's a data model not in a sense of data modeling and what comes out of it. It's a data model perhaps closer to data structure. How do we store that information? RDMS is an example of data model which is relational. We've got graph databases perhaps. And so here we've got entity attribute value, or what also is known as subject predicate object data model. Resource description framework is just that. We organize all the information we have as triplets of entity, attribute, and value, or subject predicate object. What it is, what property of it we are talking about, and what its value. This is how it looks. This is an image from w3.org, the organization which is behind this standard. And this is their illustration of how linked data looks. You can see it resembles a graph, and linked data is very often used in knowledge graphs. We have entities, for example, Alice in the top left corner, and we've got Bob, another entity. We also know that Bob is a friend of Alice. With such a simple construct, with those triplets, we can describe anything. This talk is not meant to explain exactly how it works. I've got another one where I will be looking at the technology and how it works and actually demonstrating that it works. Today, I just want to talk to you about the concepts which are not data modeling. In fact, in a moment, I will try to also show you that data modeling, the way we do it, is not only not helpful, but it probably makes it more difficult for us. But first, the problem of today is, don't we have to agree on one ontology to use linked data and stop data modeling? I'm effectively proposing, let's look at the linked data, at those graphs as shown here. Couldn't we just use something like it to represent our data? To do that, wouldn't we have to first agree what those labels are? And if so, wouldn't we just move the problem from one place to another without actually solving anything? Now, here I think we need to come back to one of the first slides and look at those different categories and the distinction between analysis and design. Why? Because we need to choose whether we are talking about analysis or design. Because if we are talking about analysis, we are subscribing to the semantic absolutism point of view. Whether we like it or not, it sort of happens. If you are thinking that you can describe something, you need to accept that that thing exists, that there is a thing you are describing. You are not creating something new. You are trying to get to the bottom of the nature of a thing. And so there's only one possible solution. The analytical approach is what we actually do when we talk about data modeling right now in the industry and especially in the civil service. So it requires that specific mindset. It requires that assumption that there is an objective truth to be discovered, and we are just trying to discover it through analysis. And I think it offers false hope that we can agree on and accept that truth. And by that, I mean, wouldn't it be nice if we all accepted what I know a company is, and we all use the same model? Wouldn't the collaboration be much easier? I think it would. But every department, every company will have slightly different opinion of what that thing is. That false hope is at the core of what we do, I think. So here you've got an example from DDAT capability framework again. This is the description from the chief data architect. In that context, data modeling is ability to understand the concepts and principles of data modeling and produce relevant data models. We do that so we can work across government and industry, recognizing opportunities for the reuse and alignment of data models in different organizations. And hopefully that shows that point of view where there is the data model for one thing, and we can discover it, agree on it, and then reuse it across the organization, across multiple departments, actually across probably the whole world. From my perspective, and here we are talking about opinions, I suppose, this is not how the world works. There is no single source of truth. And over the last few decades in technology, I think we have grown to appreciate and not only accept, but embrace diversity in so many contexts. Why not in data? I happened to be in a meeting where somebody said that the way gov.uk works, it's just plastering over cracks with simple UI, and behind there is a lot of problematic independent services. My point is that's not papering over cracks. It is a design choice. We don't have to agree. We don't have to have the same standards behind those services. As long to the consumer of them, it looks like single place of getting the services. That's all that matters. And it's been a great success. Why wouldn't we want to do something like that for data? So the typical analytical approach in organizations like civil service is very expensive. I think it's unnecessarily constraining. Just think how much time we spend trying to agree on those data models. And I really think it doesn't work. So instead, I would like to propose that we look at things differently and we think more about the design of federated systems rather than agreeing on a single truth. There are many ways to describe it. Conceptual modeling or semantic modeling is a term from paper from 1999, which focuses on capturing and representing certain aspects of human perceptions of the real world. So rather than trying to get to the nature of a thing, we are simply trying to capture the perception from one specific perspective. Then we can use things like, when we stop modeling the data, we can start looking at things like RDF, linked data, and start building systems of those little descriptive data sets rather than creating one single one in the middle. What it will allow us to do is to collaborate without coordination. And the technology already exists. So it's not utopia. It gets to a point where it's our choice to stick with those ways of working which I think don't work.